Hey everyone, welcome to the final presentation for the Paima proposal for the Navigators program. Seb, over to you.
Yeah, Brent. My name is Sebastian. I'm one of the co-founders of the Paima Studios company. So we are a company primarily focusing on building decentralized games. And within that, we work a lot with Mina Protocol to try and enable building games with Mina Protocol. Notably, the main thing we focus on is trying to combine Mina ZK tech with other ecosystems, so you can build a application that leverages Mina to power a ZK component of an application that spans across different stacks. So I'm going to share my screen to go over some of the work we've done, so you have an idea of what we've built so far and what we have coming up. But I think I need permission to share screen.
You should have it. Give me a second.
I think it worked now.
Yep.
All right, there you go. So here is our original proposal to integrate Paima engine, integrate Mina into Paima engine. Within this, we had a few different tasks. So first, we wanted to integrate the ability to sync data from Mina into Paima engine. Then we want to be able to connect Mina wallets to the Paima engine. And we want to create a template to show people how to use these. And then we want to do some research into how we can build some novel cryptographic primitives for Mina to help building games, notably VDFs, which are verifiable delay functions. So let's go into what we've built. So if you don't know, Paima Engine is our framework for building these kind of multi-stack applications. We have quite extensive docs if you want to learn about Paima Engine, how it works, and how it's set up. Notably, within Paima Engine, we created a Mina funnel, which is our way to get data from the Mina blockchain. So you can just specify a Postgres, which is your Mina database instance. So this would be like your archive node synced to Postgres. And you specify your confirmation time to avoid rollbacks and any delays. So if you want to sync the behavior of Mina contract with EVM, you can add a delay to help with synchronization to avoid like processing things too fast for rollback purposes. So I'm just gonna hop into the code real quick so you can have some idea of how this works. So I'm not gonna spend too much time on it because I know not everybody here is technical, but we do have this is like the code for the Mina funnel. So this is like the read data function, which is like, okay, given some block number range, fetch the data for that block number range. So it fetches the code, the blocks, and then we have the system called primitives, which is how to connect different actions that happen on Mina beyond just blocks to Paima Engine. So we support two things. We support actions and events. So these are both implemented using the Mina DB. So we have a bunch of SQL to like fetch the events, the actions. So to get an idea of how that looks, conceptually, when you're building an application using Paima, you say, okay, I want to use, for example, I want to use Mina, and I want to use EVM, I want to use Cardano, and I want to use blah, blah. So you specify which stacks you need. So those are the funnels we saw earlier. So you say, okay, I need like the Mina funnel, which you specify as this kind of configuration. Once you specify which networks you want, you specify what you want from those networks. And so we call these primitives. So you can say, okay, for my Mina deployment, I want to get all the events out of this address. And then we have a system called prefixes. We say, like, okay, whenever you get an event at this address, call into my state machine. So I can probably actually, that's going to be a separate tab that I can move over. Give me a second to bring this so I can show you what that looks like.
So I have a question. Is this game running completely on the network, or is it like an engine like Godot or Unity?
So I like to call Paima a Web3 engine. That's to say, usually when you build a game, there's multiple things you need to take care of. One is, of course, your smart contracts. You need to actually write your ZK app in ONJS. Then there's like building the UI and building the controller support and all this kind of stuff, which is usually a game engine like Unity or Godot. But then you need to have some kind of coordination of everything together. Like, how do you connect your ONJS smart contract to the game engine? And how do you make all that work together with, for example, somebody who's a user coming from MetaMask or from a different ecosystem? How do you deal with getting data out of that engine? How do you do these kinds of game specific like Web3 components? That kind of orchestration, connecting everything together, is primarily what Paima Engine does. So in that sense, Paima Engine is kind of like a Web3 engine. So if you want to build a decentralized application, you'll want a game engine for the front end, and then some kind of Web3 engine to help you with the coordination. So that helps kind of understand.
Thanks. Yep.
So usually. Yeah, so the way Paima Engine works is like we saw earlier. Like when we are showing you the configuration, you can see here we have like an add network. So here, like I'm showing a hard hat with EVM, but you'd replace this with like the Mina configuration I showed you earlier, with like the funnel, and then you can add primitives. And notably, like for example, in this code you see here, we have EVM event, and then it says like, okay, whenever this EVM event triggers, call a token transfer schedule prefix. And then you as a app developer, you'll specify a state machine. So you say, okay, my game has a grammar. Like for example, an attack is defined by a player ID and move ID. The switch map is defined by map ID. And also, like I'm gonna bring into my state machine all these different primitives into it. And then now when you're building a application, you can just register state transition. So you can say like, okay, whenever attack happens, I call this JavaScript code, and then whenever like a token transfer happens, call this JavaScript code. And normally these events are aggregated over multiple chains, multiple contracts, multiple things. So you can say like, okay, whenever EVM token transfer happens, call this, but then also like when a Mina token transfer happens, calls this. So it helps you kind of like build kind of abstraction over all the different chains that you're supporting, and aggregate all this as a single app. If you don't do this, your other option would be to have like your Mina code base and then your EVM code base and then your whatever code base. Like you have like your code base a bunch of different times, and then you need to somehow wrangle all this. You need to hire different engineers with different domain expertise and figure out how to combine everything together, and it doesn't really scale well. So the goal of Paima Engine is basically no matter how many chains you have a single JavaScript code base that aggregates all the different chains to support together into one experience. So you no longer need to have like 10 different devs with different expertise. You could have your smart contract developer, and then everything else is kind of like one aggregated stack. So within that, we support, as I mentioned, like getting events from Mina. We also support wallets. So when you're building an application with Paima, we have a wallet SDK built in. So of course we support EVM, but we also support Polkadot, Cardano, Algorand, and Mina as well. So you can see if you want to add like Mina wallet support to your application, all you need to do is add like wallet mode.mina as an option to like the wallet connect module, and so you don't have to know like how RO and all these other Mina wallets palette work. You just say like, I want to add Mina wallet support to my application, and Paima Engine will figure everything out, and it has all the logic for the dApp connection, the wallet selection, and all that kind of stuff. We have like templates if you want to get started. So we do have like a Mina template as well. That has like all the settings set up with the front end and all this kind of stuff baked into it. Now there's a question of I showed you the wallet support, but how do you easily get people who don't have a Mina wallet to play? Because obviously, if you're building a multi-site application, you're leveraging, for example, the EVM ecosystem. Ideally, you want people to be able to interact with your application without them having to go download a Mina wallet. Like if you tell somebody like, "Oh, you want to play this game? Like, go download Mina wallet." Most people are just going to drop off. They're really not going to download new wallet just for a single application. So to solve this problem, we built a protocol so you can connect an EVM wallet to a Mina wallet. The goal of this is basically you pay for the user's Mina gas costs on the Mina side. That way they can play from their EVM wallet. So we have a blog post that basically explains how this works. So user with a MetaMask wallet comes in, signs a EVM signature, and then we prove that EVM signature within a Mina ZK proof. So this allows you to basically connect the user's EVM wallet to an O1JS, like a Mina account. So the user can always authenticate that it really is them through this EVM signature, but we can still have an identity for them on the Mina blockchain without them having to go download a Mina wallet. So we talked about how we wrote this. Notably, there's a lot of efficiency concerns about doing this. How do you make it work in a way that the ZK app is simple enough to run and also not too slow to run? And so we have a blog post that talks about like the benchmarking of the different approaches that we could have done and how we achieve this in practice, as well as the code and how we're using this for some of our games ourselves. So we're also building games with Mina. Notably, you might have heard Click and Move, which we're hopefully going to release sometime next year. And we do have all the code for this wallet delegation inside the Paima engine. This is not on NPM yet because we were stuck on an O1JS issue originally that was only fixed last month, I believe. So we initially couldn't publish on this on NPM, but we do have all the code on GitHub and the Paima engine repo, as well as all our benchmark information about the different approaches is also in a separate GitHub repo as well. These are all linked in the Paima engine template repo. Now, with this, we can have applications that index information from Mina state and allow people to come in and play with the MetaMask wallet. And we have this account abstraction layer, and we have all that built in. The problem is that for games, you need to put as much of the computation on the user's side as possible for ZK to have any hope of scaling, right? We can't have users making every single interaction with the Mina blockchain, otherwise it'd just be too slow. So we need some way to speed up how fast the user can make actions. Now, part of that will be done through an effort called Zecco. So if you don't know, Zecco is a separate startup I've created, which is a ZK rollup framework for Mina to allow people to create app-specific rollups or general-purpose rollups with Mina protocol. And so the goal of Zecco as a separate startup that I've created is to handle these kinds of like gaming use cases where you can create these gaming rollups that are much faster for your use case, as well as we'll have like a canonical Zecco layer 2, which will be like a shared layer 2 between a bunch of different DeFi applications and so on. So we're trying to solve the performance issue partially on the rollup side. We also continue to do work on the Mina integration. So although the Navigator's proposal is done, we continue to do work. Notably, we're working on new architecture for Paima to try and integrate Zecco. So you can have like dynamic chains added to your Paima deployment. So you can say like, okay, like whenever this happens, spin up a new custom Zecco instance, run a match of the game, and then close it down after the game is over. So we're working on this kind of integration. We also do a lot of work on research for verifiable delay functions. The goal of these verifiable delay functions is to allow users to do clock computation locally. So maybe to explain why this is useful, imagine you have an RPG game. One of the most computationally intensive parts of an RPG game is when you want to do the battle system. For example, it's you versus a monster, and you take turns. You attack the attack. You attack the attack. Right? If you implement this all on chain in the regular way, every attack you do is a transaction, right? But this ends up being a lot of transactions really fast, right? If you have a battle system where the user makes an attack every second or two, just with a few users on chain, you're already hitting like the throughput limit of O1JS. This is not like a necessarily Mina issue. This is just like a, you can't easily have a million actions per second on any blockchain really. So to avoid this, we want to push the battle system off chain. So like every battle is a roll up in a sense. But the problem is, how do you do stuff like stamina bars, right? In an RPG game, you'll have like a stamina bar. You can only attack once your stamina recharges. But stamina bars are based off time, right? So for example, your stamina bar takes like 2 seconds to recharge. So how do you prove that 2 seconds have passed without being able to access the timestamp on chain? So one way you can replace the blockchain timestamp is with a verifiable delay function. So if you don't know, verifiable delay functions are a way to do this kind of long-running calculation that is non-trivially parallelizable. So it runs on a single core, and it's not ASIC friendly, so it's hard to outsource. And the benefit of this is because it means that the performance of a VDF is mostly the same across CPUs. So even if you have like a 16-core CPU, it's not so much faster because VDFs are single core processes. And so you can use this to kind of simulate a local clock. So the problem with VDFs is that nobody's built like a very ZK friendly VDF. That's an open research problem. And so we've written a blog post that goes more into depth about what VDFs are, the history behind VDFs, the common algorithms to implement VDFs, and some of the problems with them. And then we also have built a Mina implementation of those VDFs. So if you go to our repo, we do have a VDF branch. We can find our implementation of the VDFs. And you can find in the blog post the issues we ran into with the different algorithms, as well as some of the open problems that remain on how to fix these. So this blog post is fairly in-depth because we implemented quite a few things and did quite a lot of investigation into different approaches. It turns out that this is a very hard problem, but we've been fortunate to, with the work started through the Navigators program, write a pretty comprehensive blog post. And this got the interest of two different companies, one Miston Labs and two IOG. And so Miston Labs has helped us with some of their cryptography in Rust to try and help solve some of the open problems outlined in this blog post. And then we also partnered with IOG, who helped give us a research grant into doing further research work into how to implement these kinds of VDFs and recursive snarks, as well as Nova-based implementations. And so you'll see more work coming in the future about some of these open problems we have listed in this blog post getting solved, implemented in Mina. But so that was thanks to the fact that the initial work for this open research problem was funded through Mina Navigators. But you'll see the common trend in all this is that Mina Navigators helped us kickstart off a lot of these initiatives, and we are continuing to work on them with our own funding to keep accelerating Mina adoption.
All right, awesome. Thank you. Thank you very much for your presentation. I do have a question. Let's say if there's an indie game developer who wants to integrate or build their own game using these primitives, Is it at a point where they can do it or do it already? Is there SDK stable or is
Yeah,
that?
so it's at a point where we can do it already in the sense that we do have a template you can follow
Mhm.
to see how you can do it yourself, right? This is like our Paima game templates in the Mina folder. We are working on a Paima V2 at the moment, which will help make the game development experience a lot better. And that will, of course, have Mina support. So you should see that come out hopefully in December. So we'll have a lot of videos and other information coming out about Paima V2 in December. So if you're interested in that, definitely follow us on Twitter and all those platforms, and you'll hear about Paima V2 and Mina integration soon.
Good, thanks. Carol, do you?
Yeah, I have two questions. One regarding the EVM to Mina support. Would that require users to run ZK program on the client side? And if so, I saw you shown some benchmark, but how long would that take for user to kind of be able to use a kind of delegated account?
Yes, so it's all local proving.
Mhm.
So you don't do any proving for the user on a server. So we do have some benchmarks, but they're pretty fast. So
Okay.
normally there's compile time that is unfortunately pretty long. So it takes around like 30 seconds or so to do the initial compiling of the Mina circuit and all that kind
Mhm.
of stuff. But once you have it done, you can cache the verification key in the user's browser. And we use the side loading ONGS feature that's not super well documented, but if
Yeah,
we explain this blog post, there's like this side loading feature. And so just by saving like a few kilobytes in the user's local storage, you can cache a ZK program that does the verification. And so after that, the proof verification time is pretty fast. So most of the performance cost comes from having to do this initial ZK program delegation once, which is about 30 seconds or so. And after that, it's only like a few seconds overhead per proof.
I see. Cool, that makes sense. And then regarding the events and connection to Mina, you have mentioned that the events can trigger a state transition. Um,
Correct.
does that mean that the database or the actual game has to be on all the time? And what happens, if the user is not playing game currently, there's even happening on the blockchain, would that get kind of funneled in the state, or the user has to be online? I'm not sure if I understood that part.
So the state machine is populated entirely from on-chain state. That's to say, there's no centralized server you're sending your moves to that is then processing on your
Okay.
behalf. This is a deterministic state machine based off the on-chain state. The benefit of this is that it means anybody can download the state machine and run it on their own local machine and achieve the same final state. So you say, okay, I have this DApp, and this is the code for my DApp. Anybody can run this DApp, and it will start syncing a Mina node, get all the data from the Mina node, run that information from the node through the state machine, and then serve the results of that state machine through RPC and REST endpoints, all these other things. So it means that there's no dependency on like one person to have to run that state machine or host that state machine somewhere. It's all deterministically replayable by anybody else.
Yeah, that's very cool actually. So whenever I will try the game, it will literally reconstruct the state from all the events that potentially happened in the past.
Yes, exactly.
It's really cool.
Yeah, so it's kind of like an extension to blockchains in a sense, right? So the blockchain is all the data that comes directly from the chain, and then the state machine is kind of an extension to that. So we take the on-chain actions and extend it through some custom state machine.
I see. And then from perspective of kind of understanding the flow of a game with Mina in the background, let's say I want to make a move. There is a smart contract that have some logic that will do some stuff on the network itself that potentially change the state. what would be the delays like, and like how would you handle the concurrency issues as of, I make my move, do I need to wait for the full network transition? Is there something for the user experience to have better?
Yeah, so that's a great question. So part of the reason we wanted to do this kind of mixed deployment situation is precisely to help solve this problem, right? As you mentioned, if the user has to wait for the transactions to settle to Mina layer 1, it's going to be too slow, right? The bottleneck's not going to be the proof generation time. It's going to be the block time of layer 1. Because keep in mind, because for games, we can't really handle rollbacks. Like imagine you're playing a game, you beat a boss once, you're like, oh man, I won the battle, and then rolls back, and then suddenly you're like back in the boss battle. Like it doesn't make sense. So it's not only you have to wait for like the layer 1 block time, you also have to wait for a finality, which makes it even slower.
Mm-hmm.
And so the advantage of Paima supporting multiple chains is that it can allow you to have different parts of your game logic in different sections. So for example, you might have some like the initial user setup, as well as maybe some tokens on the Mina layer 1, but then have like the battle system live on a Zeko layer 2 where it's faster, we have different performance trade-offs. Or you might want to have some of the tokens live on EVM to access liquidity from over there. So it allows you to kind of take your applications. Okay, I'll have some part on the DA layer and some part on the CK layer and some part on this EVM layer, and kind of fragment stuff based off your needs to try and tackle these different constraints.
Interesting. And then from perspective of like,
maybe,
sorry, go on.
Maybe to answer like your question in another way. So there's solving this problem obviously has many steps to it, right? So one is like this kind of coordination is okay, like for performance reasons, we'll put this on these different chains, and that's great. But there's another layer of complexity that we are solving. So this is like one of the next big projects we're doing on taking on at Paima Engine, which is trying to have better local proving of long computation. So what we really want is to take these battle systems. So I can show you like we have wrong blog post. Yeah. So for example, if one of the games we built before is called Trochi, it's like a battle system, right? So you have like a 3v3 in this picture, it's 2v1, and you're doing this battle and you're submitting transactions. You have to wait for transactions to be submitted and confirmed. This is like a really bad user experience because you have to wait a few seconds for the transaction to confirm and land on chain. So we really wanted the battle system to run locally on the user's machine, and the proof that they won the battle to be submitted afterwards. The problem with this is that it's pretty hard to orchestrate this from a ZK app perspective or ZK program perspective, because we want this like a ZK program to run locally and then update the game's UI based off a ZK program, and then submit that ZK program, that ZK proof on chain, and have the game update based off that. But the problem is that if the ZK program is running entirely locally, how does the game know about the ZK program state, right? Because nothing has settled on chain yet, right? So to solve this problem, we've recently been trying to architecture a new component to Paima to try and abstract this away from a dApp developer, so that you, when you're writing your state machine, you don't have to care if it's the user local state or on-chain state. Paima Engine will handle this state for you. So take like the user local ZK proofs, the ZK program, and consider these as like optimistic updates that haven't landed on chain yet. So allow you to have kind of like these REST endpoints that are updating as if the proofs have already landed on chain, as like optimistic updates that are not finalized yet. And then like when it finally lands on chain, they go from like optimistic updates to like finalized updates. This is a pretty hard problem to solve in a way that hides a lot of complexity from the users. So this will be a long project, but if you're interested in working with us on trying to figure out how to help solve these kind of developer pain points, all of Paima Engine is MIT open source, and we do have Discord for coordination with the community as well. So anybody's more than welcome to help contribute, but of course we'll be building all this ourselves.
Cool, perfect. Thanks.
Right. I don't have any questions either, though. So thank you, Sebastian, for joining us and walking us through the work over the multiple months you've been undertaken.
Yeah, thank you very much. It's been a lot of fun, and we have a lot more work being done. So I'm really excited about where this is going.
Thanks. Have a lovely day. Bye.
Cheers. Thank you very much. Bye.